Okay, YouTube, in my last video we looked at some basic premises of probabilities. In this video we're going to look specifically at the probability of the union of two events. And so let's go ahead and confront what we mean by this. We say if A and B are events in the sample space. So here we have our sample space as a set of all possible outcomes for some experiment, and our events A and B. And you notice that in either instance here, either A and B overlap or they don't. It's one of the two possibilities here. But basically, we say the probability of A or B occurring, and I want to really point out this word or here is going to be the key, is given by the probability of A union B. Now, union, another word for union here, or another word we could put in place of union is or. We say probability of A or B. And the interesting thing is the probability of A or B would be just the probability of all this stuff right here plus the probability of all this stuff right here. It's just that you see that when we counted all that stuff up and we just add it together here, probability of A plus the probability of B. Let me switch my colors here. What you're going to see is that in the middle here, in their intersection, we counted this little portion here twice. And this little portion in the middle here, this intersection, is what we refer to as A and B. And so here's the thing. When we find the probability of two events, it's going to depend upon whether they overlap or not. But the probability of A or B is just the probability of A plus the probability of B. But we're going to subtract off one time this middle blue portion here. So basically, you can almost imagine that we would have added all of this up right here, and then we would have added all the other part of it up right here, kind of try to illustrate this right here. And then what we would have done is would have cut out this middle portion right there one time, this like right there. We would have subtracted off once. And so basically what we get is something that looks instead like that. But when you add them together, it represents all of their stuff there. So we say the probability of A union B, or A or B, that's the key word there, is probability of the first thing plus the probability of the second thing minus the probability of anything they may have had in common. Now the nice thing about this formula is that it comes in two different packages. Now I'm going to say the one that I just circled in purple here, this is the one you want to know off the top of your head. But basically, if they don't overlap, if the A and B is the null set, if we said A intersect B is really just the empty set, there's nothing they have in common, then we say, well, then the probability of A or B is the probability of A, which is all this stuff, plus the probability of B, and I don't need to subtract off what they have in common because they had nothing in common. What I would like to argue is if we did do this, when we add this in, then really what we're doing is we're subtracting off 0 because this is an impossible event. There was nothing that was in A that was also in B. So we would say that that wouldn't happen right there. So looking at how this would come into play, let's look at an example where we talk about a standard deck of 52 cards. Now, a standard deck of 52 cards, I want to be clear on this one. We have spades. I'm going to write this out. Spades, diamonds, hearts, another red suit there, and clubs. And I didn't put any reason to this rhyme right here, but we could say that the middle two right here, these two are red, okay? And this one's black and this one's black. In terms of how many cards are an entire deck, we'd say 52 cards are an entire deck. So we could say 26 red and 26 black. Sorry to go through this, but I find some people don't know what these cards are. And then within every suit we have ace, and then it goes 2, 3, 4, all the way up to, we'd have 10, jack, queen, king. And so every suit is kind of ordered in this right here, but we'd say every suit has 13 cards per suit, and it has 4 suits. Okay, 4 suits. And so what we're going to look at here is this. We say, what's the probability that the card is either a heart or a face card? So rule number 1 in probability is this. Write the desired probability symbolically. Probability symbolically. And so what I mean by this is, just read the last sentence here. It says find the probability it's either heart or face. So I'm quite literally going to write down the probability that it's a heart or a face card. Now the interesting thing about this is this word or is sticking out to me now. And as I look back at my formula here, it just says, well, then the probability of A or B is probability of the first event plus the probability of the second event minus the probability of anything they had in common. So when I look at this here, we could almost look at it as this right here. We'd say here's the set of all 52 cards in a deck. And when we represent the hearts here, this will all represent, this is my hearts. I'd say hearts, there are 13 cards in this entire bubble right here. Now when we talk about a face card, this could be a jack, a queen, or a king. An ace is not a face card, but see we have 4 suits here. So 4 times 3 would have 12 total of those. But I think the idea is that every suit has face cards in it. And so these two sets overlap. So once we write down our probability, we're going to rewrite using probability rules. Now, probability rules, we just learned the addition rule, probability rules. And in terms of probability rules and the addition rule, we say if we see an or, we could rewrite this as addition. So we say probability of a heart plus the probability of a face. Now here comes the kicker. We need to subtract off this middle portion here, which we refer to as minus the probability of their intersection. So we say a heart and, I'm going to write and a face. And we could also write an intersection right here. So with respect to what is the probability we get a heart? Well, now, out of all 52 cards, the probability we get a heart, there are 13 hearts in its suit. There are 13 cards in every suit. So we say there's its probability. Now let's find the probability that it's a face card. So we counted 3 per suit, 4 suits, 12 face cards. Here's its probability. Now what we need to keep in mind is this. Of the 52 cards, how many are in the suit of hearts and a face card? And so since every suit has 3 face cards in it, we would say that we'd take off this 3 right here. And really what happened is this. We're saying that 3 of these cards are faced and hearted. So we would say if 3 are right here, then the other 10 are out here for a grand total of 13 hearts. And if 3 of these face cards are in here with the hearts, then we say there are 12 total face cards. 9 of them are out here for a grand total of 12. We can see that 10 plus 3 plus 9 here really is 22. And what we're going to see here with our probabilities is essentially this. We have 13 50 seconds plus 12 50 seconds is 25 50 seconds. And 25 minus 3, we get 22 out of 52. So really quickly, I do want to reduce this. This would be 11/26. If you can possibly reduce it, then you should do so. And also we want to get a decimal for this as well as a percentage. So 11 divided by 26, we get approximately 0.4231-ish. So I'm going to write that 0.4231-ish. And we'll usually go 4 decimal places because what I want to do now is also represent this as approximately 42.31% chance is our likelihood of this event occurring. So looking at this again here, we say, what's the probability that it is a heart or a club? Now I like this situation. We're going to start with our steps again here. Write the desired probability symbolically. So the first thing I'm doing, I'm writing down what's the probability it's the heart or a club. Now we're going to rewrite this with our addition rule because of this or right here. But we say the probability of our first event, heart, plus the probability of our second event, which is a club, minus the probability that they have anything in common, heart or a club, and a club. So one thing I didn't do on this one was draw a picture of the situation, which would have been helpful here. What you're going to notice is this. A heart and a club can't be both a heart club. You can't be a heart club. So when we look at this, you look at this, we say, here's all the hearts, and here's all the clubs. I'll label this here, heart, club. We have 13 over here, and we have 13 over here, and none in common. So the probability that you grab a heart or a club is the probability of a heart, which is out of 52, there are 13 of those things, plus a probability of a club, which is also 13 out of 52, and this is minus any that they had in common, and they had none in common, so I'm going to write minus 0. So really we get 26 out of 52, which makes reasonable sense because that would be a half. Half of our deck is either a heart or a club. We'd say that this is 0.50 and also 50%. So that's what we do when we find probabilities of unions of events. We have to just add the probability of the individual events and subtract off anything that they had in common.